All right, today we are diving into a design pattern that is all about bringing order to chaos, the abstract factory. Now, this is a seriously powerful way to manage groups of related objects, and once you see how it works, you'll get just how elegant and, well, useful it can be.
So, let's kick things off with a problem that I am sure is painfully familiar to a lot of you. You're building an app, right? It's got a light mode and a dark mode. You've been super careful, but then it happens. A bright white button shows up in your sleek, dark window. It just looks wrong. It completely shatters the user experience. So what's going on here?
Well, the root of this evil is almost always direct creation. You know what I'm talking about. Our code just gets littered with calls like new light button here and a new dark checkbox over there. It seems fine at first, but this approach, man, it spirals into a tangled, unmanageable mess that is just impossible to keep straight.
This way of doing things creates three huge problems. First, there's absolutely zero guarantee that the objects you're creating actually belong to the same theme or family. Second, your main code gets handcuffed directly to concrete classes, like a motif scroll bar. And because of that, trying to switch the whole look and feel of your app, it's a total nightmare. You're just hunting down every single instance and hoping you don't miss one.
The real solution here requires us to flip our thinking on its head. Instead of our client code creating all these scattered individual objects, we're going to introduce a powerful middleman, a factory. We're going to ask it to create an entire family of related objects for us, making sure they all match every single time.
And this leads us straight to the classic definition from the Gang of Four, the folks who literally wrote the book on design patterns. The whole point is to provide an interface for creating families of related or dependent objects. And this next part is the key, without specifying their concrete classes. Your client has no idea if it's getting a motif-style widget or a presentation manager-style one. It just knows it's getting a widget.
Let's break that down into simpler terms. Think of an abstract factory as a specialized machine. You've got one machine, the light theme factory, and it's tooled up to produce a whole set of light-themed products. Light buttons, light checkboxes, the works. Then you've got another machine, the dark theme factory, for the dark-themed family. The critical thing here is that each factory guarantees that everything it spits out is consistent within that family.
And here's what that structure looks like in our UI example. Up top, we have our GUI factory. That's the abstract interface. It's just the blueprint. It says what any factory needs to be able to create. Then, underneath, you've got the concrete implementations, like Motif Factory and PM Factory. And notice how Motif Factory only creates motif products. This is how the pattern automatically enforces that consistency for us.
So this right here is the official, big-picture structure of the pattern. I know it might look a little intimidating at first glance, but trust me, it's very logical. On the left side, you've got your factories, and on the right, you've got the products they make. So now let's break down who the key players are in this system.
There are really 5 key players on the field. The abstract factory is the contract, the rules of the game. The concrete factory is the actual worker that builds a specific family. Then you have the abstract product, which is the interface for a product, like a generic button. And the concrete product is the real thing, like a motif button. And finally, and this is the most important piece of the puzzle, the client. It only ever talks through the abstract interfaces. It has no idea what concrete classes it's actually using. It's completely in the dark, and that's a good thing.
So at runtime, this all plays out in a simple 4-step dance. First, the application starts up and gives a specific factory, let's say it's the motif widget factory, to the client. Second, when the client needs a scroll bar, it doesn't build one itself, it just asks the factory. Third, the motif widget factory gets to work, cranks out a brand new motif scroll bar, and hands it back. And finally, the client uses this new object, knowing it only as a generic scroll bar. It is completely oblivious to the fact that it's a motif one.
And just look at how clean this makes the client code. Somewhere at the beginning of our program, we decide on a theme and create our specific factory, in this case, a motif factory. From that moment on, anytime we need a widget, we just ask our GUI factory. Now look really closely. The code that asks for the scroll bar never even says the word motif. It is completely and beautifully decoupled.
And right here, this is the magic. This is the big payoff for setting up all that structure. If you decide you want to switch your entire app's look and feel from Motif to Presentation Manager, you don't go on a wild goose chase through hundreds of files. No, you change exactly one line of code, the line where the concrete factory gets created. That's it. Everything else in your application stays exactly the same. It's just incredibly powerful.
So let's just step back and really appreciate the difference here. Before, our code was a brittle mess, hardwired to every single widget and basically guaranteed to have consistency bugs. After implementing the pattern, our client is totally isolated, only speaking through abstract interfaces. The result is clean, flexible code where consistency isn't something you hope for, it's guaranteed by the design itself.
But, no design pattern is a silver bullet. They all have trade-offs. The pros here are huge. You isolate your concrete classes, swapping entire product families is a one-line change, and you get guaranteed consistency. But there's a pretty significant con. What happens if you want to add a whole new kind of product, like a text box? Well, you have to go all the way back to the abstract factory interface and add a create text box method. And that forces you to update every single concrete factory you've ever written. That can be a whole lot of work.
So what are the common traps people fall into with this pattern? The biggest one, by far, is over-engineering. If you're only ever going to have one family of products, this is definitely overkill. You also have to keep that main drawback in mind. If your system is constantly adding new types of products, this pattern is going to cause a lot of maintenance headaches. And finally, it's pretty easy to confuse it with other, similar creational patterns.
Now, this isn't just some academic thought experiment. This pattern is used all over the place in the real world. The classic example, as we've seen, is in UI toolkits for handling themes. It's also used to build portable apps that can run on different operating systems or windowing systems without changing the core logic. Basically, anytime you need to configure a system with one of several complete sets of components that have to work together, Abstract Factory is a really strong contender.
Now here's a question that comes up all the time. You look at one of those concrete factories, and you see methods like create button and create scroll bar, and you think, hey, each one of those looks like a factory method. So is an abstract factory just a fancy container for a bunch of factory methods?
The answer is no, and understanding this difference is super important. The factory method pattern is all about creating a single object. The abstract factory pattern operates at a much higher level. It's about creating entire families of objects that are designed to work together. You can think about it like this. An abstract factory is often implemented using a bunch of factory methods, one for each product in the family. But their goals are different. One object versus a whole consistent set. Okay, let's do a quick recap of the most crucial points. What is it? A pattern for creating families of related objects. Why do we use it? To guarantee consistency and keep our code flexible and decoupled. When is it a good idea? Anytime your system needs to be configured with one of several complete product families. And how does it all work? The client talks to a factory through an abstract interface, completely unaware of the nitty-gritty details.
And that, in a nutshell, is the Abstract Factory pattern. It's a fantastic blueprint for building systems that are both flexible and super robust, making sure that components that are meant to be together actually stay together. So the next time you're designing a complex system, just ask yourself, am I going to risk chaos by building these things one by one, or am I going to build a factory? Thanks for tuning in.